Okay, so these are the plug and chug um, for chapter 4. These are the practice examples, so let's go through these. So first we know Bertha has a mass of 50 kilograms. Stop right there. Let's write that down. Kilograms. And we also know that the acceleration due to gravity is 9.81 meters per second squared. So the formula, and either one of these two will do, F equals ma, and we're looking for weight, so that's technically Fg, so we have to use A sub g. Notice that they're exactly the same formula. This one is for weight, but remember weight is actually a force. So weight, Fg, equals 50 times 9.81. And when you do that out, that's not the right paper. When you do that out, you end up with 490.5 newtons, because newtons is our unit of weight. Next one, calculate the weight of Edgar. So we're looking for Fg. Edgar the elephant in newtons. He has a mass of 2,000 kilograms. Now, it appears as if we don't have enough information, but we also know that the acceleration due to gravity is 9.81 meters per second squared. So again, we're going to use the same formula, Fg equals mag. We could have used F equals ma, the FMA formula. Either one works quite well in this situation. So let's plug into that formula. Fg equals 2,000 times 9.81. Multiplying those two together, you get 19,620 newtons. Awesome. Got to move this up just a wee bit for the next couple of problems. Okay, calculate the weight, so Fg again, in newtons of a 2.5 kilogram. Now, what is kilograms? Kilograms is a unit of mass. It's 2.5 kilograms. And again, we know the acceleration due to gravity is 9.81 meters per second squared. Again, same formula. Gonna get sick of it after a while. Maybe not. So Fg equals 2.5 times 9.81. And when you do that one out, you're going to get 24.53. Now, what's the unit on that? Well, we're looking for a force, so that would have to be newtons. So now it says use the weight calculated in part A. So force due to gravity is 24.53 newtons. Calculate the watermelon's weight in pounds. So we also know 1 newton equals 0.22 lbs. Nothing really to do here, but we got to do a little factor labeling over here. 24.53 newtons. Now remember, whatever the unit is up here, we're going to put it down here. And what are we trying to change it into? Pounds. So let's put in the numbers. So over here it says 1 newton is 0.22 pounds. So we're going to multiply those two numbers together. And we're going to end up with 5.40 pounds. And I think it rounds up, it's like actually 5.399 or some nonsense like that. In this case, this 0 is okay. All right, next one, which you can't see, so I got to move the thing down again. We have an artichoke weighs, so force due to gravity is 1.5 newtons. What's the mass in kilograms? So one would think that one doesn't have enough information, but we know that the acceleration due to gravity is 9.81 meters per second squared. We're going to use the same formula. And let's plug in here. So we got 1.5 equals the mass times 9.81. We're going to have to divide both sides by 9.81. 9.81, so it gets rid of that. So now we have mass equals 1.5 over 9.81. And when you do that out, it's 0.15. Now, what are we looking for? Mass. What's the unit of mass? Well, it tells us. It's in kilograms. There you go. Last one. Gertrude Gravity finds she weighs 300 newtons. So force due to gravity equals 300 newtons. Calculate her mass. So we're looking for her mass. We know the acceleration due to gravity is 9.81 meters per second squared. And we can use our favorite formula, the FMA formula, or my favorite formula at least. So we got 300 equals mass times 9.81. Divide both sides by 9.81, just like we did the last one. So we get mass equals 300 divided by 9.81. Now at this point you should take a look at this and say, is it going to be a number greater than 1 or less than 1? Well, obviously, since the numerator is greater than the denominator, it's going to be much greater than 1. How much greater? Well, 300 divided by about 10 is about 30, so it should be in the neighborhood of 30. As a matter of fact, it's 30.58 kilograms. Okay. That takes care of those 5 problems. Thanks for joining me. Have a good day.